David I here, and time for another developer skill sprint. Tips, tricks, and techniques you can use immediately. This week's skill sprint is Delphi anonymous methods and C++ lambdas, when to use them and not use them. There's my email address and my Twitter handle. And down at the bottom is the short URL for the blog notes for this skill sprint, embt.co/skill-anon-lambda. This skill sprint works with Rad Studio, Delphi, and C++ Builder 10 Seattle. It also works with App Method. We've got the DocWiki links up there on the right-hand side. You can use these sample programs. In this case, I'm going to be using multi-device applications for Delphi and C++ Builder. They run on Windows, Android, and iOS for C++ 11, and they run on Windows, OS 10, Android, and iOS for Delphi. What we're going to cover today is we're going to take a look at some syntax and example for Delphi anonymous methods and C++ 11 lambdas. I'm going to use the parallel programming library for Delphi and C++ Builder, and I'm going to talk in just a moment about when to use them and when not to use them. Mostly it'll be when to use them. This slide has a quick look at the syntax for Delphi and C++ Builder anonymous methods and lambdas. For Delphi, it's a procedure function with no name. It might take parameters and then statements inside of a statement block. For C++ 11, there's a capture list and the body without a name. Or you can have a capture list and some parameters and the body. Or you can have the capture list, some parameters, and a return type, and then the body of statements. Or a capture list with parameters. It can be mutable, that's optional. There can be an exception attribute, a return value, and then the body of the function. Just a quick slide on C++ 11 lambda capture list. It's a comma-separated list of 0 or more captures, optionally beginning with a capture default. The capture list can be passed as follows. The empty square brackets means nothing is captured. If you want to pass the this pointer, then put this inside of there. And then there's other options for capturing all automatic variables in the body of the lambda by value or by reference. This is actually from the code I'm going to show you in a minute. You'll see I'm using the task run method as part of the parallel programming library. And inside of there, I have two anonymous methods for Delphi, an outer one and an inner one. The first one is an anonymous method as the run parameter. The second anonymous method down lower is an embedded anonymous method where I use the thread synchronize call to update what's happening in the program. On C++ side, we use lambdas, so I again use the task run method. I pass it a lambda that is doing the sleeping and processing, and then an embedded lambda that is doing the output. The advantages of anonymous methods and lambdas are it's an easy way to define and use the method power inline in your code. Allows you to parameterize using code just as you would normally pass function pointers or procedure pointers or method pointers. You can bind the anonymous methods to variables in the context of your application and in your code. It avoids the direct use of function and procedure pointers or method pointers. It doesn't introduce a new name just for a temporary use. And using anonymous methods and lambdas allows you to place your code right where it's called in your applications instead of calling somewhere else in your program. That improves the code clarity in your applications. Now, when to use them and when not to use them? When to use them, when you need a small method that's not meant to be reused, you can just create a lambda or an anonymous method. You get all the benefits of method, variable binding, and hiding in line in your code. And if you use a runtime library that requires them to be used, the parallel programming library, for example, these languages support the use of those types of libraries. When not to use them, there could be all sorts of reasons, but really the only one that I think makes sense is if you're building a library that's going to be used by some other programming language that doesn't support anonymous methods or lambdas, then you'll want to avoid using those in those libraries that you're building. And maybe you have other ideas when to use them and when not to use them. We'll talk about that if you want in the Q&A at the end. So let's get to the sample code. To start the demonstrations, I have two simple examples, one for Object Pascal and one for C++. I've just got a button and a label on each of the user interfaces. The code behind for Delphi has a function called makeAdder, which is going to take a parameter as a function event. A function event is a reference to a function that is an anonymous method. Inside of makeAdder, I've got an anonymous method that's going to take X and add y to it. Down in the body of my example, I have my adder, which is also a function of int. I'll set x and y to 20 and 22. I'll set my adder to be make adder, passing the value of x, and then I'll use adder, which is a function of integer, passing y to it to add x and y together and store that into the label's text by converting it to string. Let's look at this example in action. So we just click on it, the value is 42. Over here in C++, we've got source code that has x and y set to 20 and 22. We'll set sum equal to a lambda, passing in x and y, and then returning the sum of x and y. And then we'll just say label one text string, call sprintf, call the anonymous method sum, passing in the x and y values to get the result. Let's look at this example in action. And again, we get the value 42. Now let's look at two more examples that use the parallel programming library task method, which takes an anonymous method. We have examples for Object Pascal and for C++. So first, for the anonymous method in Delphi, I've got a multi-device application that'll run on Windows, OS X, iOS, and Android. It's got two buttons and a memo and a toolbar. The first button will execute task run, passing it an anonymous method, the procedure. We'll define a couple of variables that we're going to use. And then inside the body, we'll have a for loop where we'll sleep for a while, increment a value, and then we'll call thread synchronize to output the current state of the running of this method. And we have an inner anonymous method that outputs the date and time and the current state, whether it's working away or completed. And then the second button click just outputs the value as a string with the date and time along the way so we can see how it's progressing. For C++ 11 lambdas, we call the same task run method in the parallel programming library. We're going to create a lambda with no parameters. In the case of C++, I need to put a capture variable in the square brackets that allows me to access the variables inside of my form. So I pass the this pointer in. We initialize a constant iterator. We do a for loop, do a sleep, update the value. The value variable is defined as a private variable in our form class. And then we call thread synchronize. Here we need to pass in the capture variables this and the value of I so that we can test to see if we're done iterating through or not. And otherwise we'll output working away versus done. And then the second button click just outputs the date and time of the private variable value. And over in our Pascal program, we've also got a private variable, the same variable, an integer named value. All right, so let's run the Delphi example. So we'll start the background task, and we'll just start showing the variable. Now notice it's working away after it's been sleeping, and we can wait for a while, and eventually it will complete, and we've got the final value. Let's go to the C++ version. Let's run that. Again, we'll start the background task, show the value. As it works away, it increments that private variable named value. Well, some people might say, well, you know, if you need to use an anonymous method multiple times in your code, you don't necessarily want to have to repeat all of this code over and over throughout a larger program. You can assign a reference to the anonymous method or the lambda and then use it elsewhere in your program. Some other people have suggested that if your anonymous method is too large, you should just make it a separate method, a separate procedure or function. I'll leave that to you. If your lambda or anonymous method is a small little piece of code, like this example, then just define it in line and use it in line.
Let's look at some demos that do something with anonymous method. And one thing is to use anonymous methods for event handlers. Now I've created this custom button, again, usual concept of interceptor class, because I don't want to reinstall the component. So this has an anonymous click event handler, which is not technically an event handler, but rather is an anonymous method event. So it's a reference to procedure, not reference to an event. So this is the mechanism. This is how you can save it. There is an assign button that basically what will do, this is how you assign an event. Again, it's not really an event handler, an anonymous method to this kind of anonymous event. and then you can invoke it when the button is clicked. So say if there is an event assigned, do a non-click. So when you click on the button, this anonymous method is executed rather than and also the standard event handler is executed. Now let's run this because it is also a little surprising. Okay, button invoke, and again I can keep the reference. And what happens here? Let's look at this keep ref. This is a slightly different assignment. Is it gone? Keep ref. So here what I'm saying, I have a component which is the sender. I've spelled it out for clarity. So I have a component reference, which is the sender. So the button that was clicked and caused this event handler. And then I'm using this component reference inside this show message. So there is sender st button. This is the button that's been clicked to execute the anonymous method. But this is the button that was clicked when I did assign the anonymous method of this variable. This variable is captured. So what I can do here is actually, if I do keep ref, I press invoke. And so this has a reference to the button that was clicked, button invoke, but also that with the button that was used to assign the anonymous method with this button keep ref. And this is kept around. Again, this variable goes out of scope, and is captured, and is kept around in the event handler. So again, this is how you can actually get a lot of information. This is also another example. 4 mouse down. So when I'm clicking on the mouse, I'm creating an anonymous method that keeps a reference to the X and the Y position where the mouse was pressed. Oh, sorry. So if I run this application again, and then I press invoke, so it basically tells me the position I originally clicked, and that was captured by the anonymous method. So that was the last left click position. And again, rather than storing the information in a regular variable, I'm basically storing it in the anonymous method, which is kind of awkward, but again, extremely powerful as a way of getting this information. So this is another anonymous method, another integer procedure. Now you can assign this getShow method to the integer procedure. So sorry, getShow method is a function that returns an anonymous method. As odd as it seems, that's legal and it's possible. You can return a method, an anonymous method from a function. And again, this will also capture, like for example, X, the local variable used here. Okay, so this returns a method. If you just call it, you're calling it, but then the result is lost. So you basically want to call it and assign back the result. Now, if you try to type it like this, you get an error because it will try to execute the result. So you really need the extra parenthesis in this specific case, because you need to make sure this is executed, but the resulting procedure is actually kept around. And in fact, you can call it and invoke it. And another way of writing the same is this, which is call the function that returns the anonymous method and then call the anonymous method as parameter. Now, this double parenthesis is really awkward, but so I'd rather suggest, using this syntax, but technically it works. So you can do this double parenthesis because the first parenthesis returns the anonymous method and the second is the parameter passed to the anonymous method returned by the first call. So you are chaining, well, not even chaining, really hooking one call to another call. There is another quite surprising way to do the same, which is called invoke. What is this invoke? Oh, let's see what this anonymous methods are. Oh, query interface at ref release. That sounds familiar. This is actually an interface, and automatically the anonymous method is mapped to this general invoke operation of the interface. So again, not something you generally want to write because it looks a bit ugly and like out of nowhere, but technically this will work.
Here are some links to DocWiki articles on anonymous methods and C++ lambdas. I also have a link to a C++ reference on lambdas. There's a great chapter on anonymous methods in Nick Hodge's Coding in Delphi book. And also, we're going to cover much more in Code Rage 10, which is coming up in the middle of October, October 13th to 15th. You can register now for Code Rage 10. And also, the code for this skill sprint is on Code Central. There's the URL. Just use item 30383. Next time, the skill sprint is titled Effective Live Bindings from Forms to Code. You can see the whole schedule and replays link at the short URL there on the screen, embt.co/sprint15, capital S. It's Tuesday, the 29th of September. That'll be the last skill sprint for this quarter. Just want to remind you that we have Rad Studio 10 Seattle offers. The early bird discount, 10% off until September 30th. If you have an older or earlier version of Delphi or C++ Builder or Rad Studio, you can get the upgrade price. We also have a special offer for those new purchases and upgrades. Buy one tool, get a second tool for free. If you have 10 Seattle or you're on maintenance, go to your registered user download area. You can download the ebook More Coding in Delphi by Nick Hodges, the Essential Pascal Handbook by Marco Cantu, the VCL and FireMonkey Premium Styles, and the Media Converter to convert your VCL apps to FireMonkey apps. Check out all the details and the terms and conditions at Embarcadero.com/rad offer. Also want to mention that we have the new Rad Solution Pack. It's the ultimate collection of VCL and FireMonkey tools and components for Delphi and C++ Builder. It includes Schema T-Chart Professional, Fast Report and FastCube by Fast Report, Wall-to-Walls Grid Components, InfoPower Grid, and Power Grid, the Kanopka Signature VCL Controls, version 6, CodeSite Studio 5, the Radiant Shapes, App Analytics, and Beacon Fence license keys. They're available in the VCL Only Pack, the FireMonkey Only Pack, and the Complete VCL and FireMonkey Edition. All the details, including what parts of technologies are included in each of the packs and what versions of all of these tools that we're shipping, all that information is available on the Embarcadero.com/products/Rad Solution Pack. And now it's time for questions in your own experience with using anonymous methods and C++ 11 lambdas.
Dave asks, is anonymous method really required for parallel library? I'm sure I replaced an anonymous method with a standard one before. Perhaps they are overloaded methods. For the parallel task, it does take an anonymous method or an interface to a procedure. And the sample, I think, if you go into the DocWiki and look at the code, in the parallel programming library, there are a bunch of tutorials that you can take a look at, and also there's the using the parallel programming library. You can see the methods, for example, for task, for parallel for and future. So the answer is yes, but there are many ways to pass. Let's see. Now I don't want that link. Let me put the link to the DocWiki for this one. Okay, hold on. It's early morning here, so copying and pasting is always okay. And why are they called lambdas? Well, in C++, that's just the name they gave it. Lambda functions similar to a functor or a function pointer. They're similar ideas. They just gave it the name lambda. Maybe it's in homage to lambda function.
Lambda calculus, I believe, is where it comes from. Yeah.
Lambda calculus. So as kind of a programmable interface, yeah. But it's a name. Some people use other names, but that's the name that the C++ committee gave to them. Let's see. Like this. Let's see. Lucky I use Pascal. I just hate this square bracket, parenthesis, void stuff. Well, I don't know. We won't have a battle of language syntax here. Language syntax battles.
It's interesting talking with C++ and C# developers, the idiosyncrasies that bug them about Pascal. I'm like, really? That bugs you? So to each his own, I guess, is the moral of the story is everybody has something they like and dislike about languages, and that's fine. That's why there's so many to choose from.
Yeah, some of the early Lambda function work started at the Boost Libraries project, and then was picked up by the committee. So, as far as I've had some discussions with Alan Bauer and others internally about when to use them, when to use them. It's like all sorts of times. When not to use them. I mentioned, if you have a very long body if you find yourself creating a very long body of a anonymous method or a lambda, then probably make it a function. Put it outside and have an interface that you declare. A reference that you declare, or just have it be a function. There was some discussion about, was it more efficient or not? It's still a call ultimately to an unnamed function that gets created and put in memory. So it's still making that call from a library or whatever. So there isn't really any overhead in that respect as far as speed or code size or whatever. So you can't, you could try to go down that path, but then it's the same path as if you were calling external functions and procedures, or if you were passing around function pointers or method pointers. To me, and it fits in nicely with the C++ or modern C++ efforts to make the language more expressive, number one, and number two, to make it more safe. Instead of passing around these functors or pointers to functions everywhere, that gets really hairy if you don't know what you're doing. Having a way to describe an unnamed method and not have to deal with pointers is a good thing. I mean, less pointers, more code, always good. There was some discussion about, was it larger in code? No, it's not. It still is a procedure or function or method that has an internal name, in a sense, but there's nothing that really explodes in the sense of size of code or speed of code. So unless others have their thoughts about when not to use them, I'd say use them if you have to. For example, if you're using a library that takes some kind of reference to a procedure, function, or method, and use an anonymous method. Again, the parallel programming library does that in its places, like in the task run. So you're forced to do it, and we have that support now in C++ Builder 10 Seattle for Win32, Win64, iOS, and Android. Let's see.
So it would appear the URL for the Rad Solutions pack is offline at the moment.
Did I? Let me look.
I just checked it. That's right.
They may be doing some maintenance on the page.
Yeah, I emailed the web team. They'll get it fixed.
All right. Yeah, I know they've been working on some of the things. Okay. But that's it, short and sweet. Skill sprints are 10 to 15 minutes or so. Try to show you how to use them if you've never used them before. I think the parallel programming library is a great thing. You saw in the second examples, you get this responsive UI because you start parallel tasks, and that was tied into using anonymous methods and lambdas under the covers there. So you could be clicking on the user interface and have it continue to work, which is really cool. There are many more things you can do with these anonymous methods and lambdas. You can assign them. You can, call them in different ways. There's different parameter passing mechanisms. So depending on what your needs.
I found that in a lot of times in my code, I'll end up writing my own things that accept anonymous methods, and that's really gets powerful at that point when you start making calls that accept anonymous methods as parameters and things you can do with that. It's pretty neat.
Before we had anonymous methods and lambdas in the languages, it was function pointers, right, and procedure method pointers. So if you have old apps that still are working and using those function pointers, procedure pointers, you should think seriously about updating them as you move forward in our compilers and languages. Let's see. There's a question here about why in code completion is anonymous method does not work for variables. I'll have to take a look, Laszlo. I'm not sure if what you're saying is if you're passing parameters into an anonymous variable and you hit the parenthesis and you don't see variables. I'm not sure what. Okay, let's see. Do you mean for parameters? That'll be an interesting. I'll check that out, and let's see. Okay, send me an email, Laszlo, and if there's something I need to show, I can update for the replay of the video. Let's see. Is it advisable to use anonymous methods as compare functions for sorting, which require function pointers previously? That's another great example, and I think that example is used in a couple of articles that I found. That sorting, the comparator for sorting is a great way to use an anonymous method or lambda. I think I shouldn't say any. Most places where you have the requirement for function pointers are good candidates for using anonymous methods and lambdas. And what I'll do is I'll work on an example for each language and add it to my code and video. So that's a good another example. I'll do that. I'll add that to the code. And again, the code is on Code Central. So you can go to, I think it was, what did I say? It was 30383. I always forget. If you go to my blog, that's probably, if you go to the community blog and then on the blog menu, David I sip from the fire hose from the pull-down menu, you'll see the blog post. And it's got some notes and it's got all the links at the end. So let me, I'll copy the link address and put it in the chat window so that you can all have it. Here you go. I also put the link to to the blog post itself. So, and there you go. So it's item 30383. And I haven't added the slides yet, but I'll update the Code Central entry to have the slides in there. It has the 4 projects in the zip file that is in that entry 30383. But I'll work on, I think our DocWiki has a sort example, and I'll do a C++ example. I think having a sort comparator is a great idea. A good point. And if you can send me an email, davidi@embarcadero.com, DAVIDI, if you need other links or if you want to see some other samples in specific ways. It's a pretty simple topic. Maybe looks complicated if you're a Object Pascal programmer when you see the C++ side, but and the same thing might be said for vice versa. I don't know. But I've got the links again on my blog page to the DocWiki entries for both. So let's see. When will there be a solution to work in parallel with grid as there's with Open ACC, for example? Open ACC, work with a grid. With grid. let's see. Oh, parallel computing. Oh, I see. Well, for me, I had to understand what OpenACC. I use OpenCL for GPU computing. That's what I use. There's a Delphi interface unit and C++ samples as well for doing GPU computing. But I guess I'll talk to Alan Bauer to see if he's thinking about adding GPU parallel computing to the parallel programming library in the future. The one that we ship right now, PPL, is just a starting point. Alan has other ideas for more things to add, including functionality separate from GPU computing. So, or there's the CUDA programming language that NVIDIA has that people use. Right for now, I use OpenCL. It works with Delphi and C++ Builder. So you might check out OpenCL for GPU computing. But I'll take a look at OpenACC. There's others that are out there for people that are doing GPU computing as well. So,
okay. I have applications where a thread needs to wait for an event in order to proceed because the value is set in a second process. How do you do that with anonymous methods and tasks?
Well, in tasks and task run, you can create an array of tasks by using the interface or iTask, and then there's a wait for any, wait for all. You can also look at the status of each task. Is it running? Is it stopped? And so on. So all of that is documented in the parallel programming library, and we've covered that in skill sprints and code rage sessions, deep dives. So there's videos on YouTube and everywhere, and it's also documented on the doc wiki for the parallel programming library. So wait for all, wait for any, and again, with an array of tasks, you can, regardless if those tasks are running anonymous methods or not, you can check the task status of each one.
So where can you learn more information about anonymous methods and parallel programming? You kind of touched on that one just now, didn't you?
Yeah, but the two places that I always go to, separate from the doc wiki, Marco Cantu's Object Pascal Handbook, he's got a whole section on anonymous, a whole chapter on anonymous methods, and Nick Hodges' Coding in Delphi that I link from on my blog. I'll also put a link to Marco's book. I'll update the blog. But Coding in Delphi has a whole chapter on anonymous methods as well. Buy both of those books. If you have 10 Seattle, you can get the Marco Cantu Object Pascal Handbook ebook version. But go out to the links Coding in Delphi and Marco Cantu's Object Pascal Handbook. You can get the print copies or the ebook copies and read those chapters. They're great. There also is information in the doc wiki all about using anonymous methods. There's a whole section. I have the link to that as well. As far as parallel programming, those are covered in the books and in the doc wiki.
So Neville has a question here for you. It says, in Delphi, if you have a property or variable declared as an anonymous method, is it possible to assign a normal method to it, assuming it has the correct signature?
As long as it has the correct signature. If it has the same parameter list, so if it's meant to be an event handler, something like a sender of type T object, but yeah, as long as the signature is the same, you can assign them.
So now, in the example Marco showed there, he was assigning an anonymous method to an event handler by using that interceptor. So yep. You don't have to, the other way around, you can assign an event handler to an anonymous method without an interceptor of some sort?
Yeah.
Okay.
And then you can typecast things. There's all sorts of different options. And again, in the doc wiki for anonymous methods in Delphi, we could put that link in. It's linked off the blog post for this one. It goes through all the different kind of using anonymous methods, doing variable binding, events, and so on. So assignment, using code for parameters, and on. But Marco and Nick both go into even more detail in their books and their ebooks. Okay, well, I don't see any other questions. I'm not sure. Yeah, there was some connectivity issues for one attendee, but I don't know what's going on because we had a bunch of otherwise that were totally connected.
So Nick's saying, in Objective-C, a block can reference variables in the same procedure it is called from. Is it the same for anonymous methods?
Yes, if you're inside that block, it's sort of self is implied. So you don't have to do anything special. In C++ Lambdas, it is not implied. You have to put this pointer in the capture list, or at least variables that you want to refer to that are in the sort of outer containing that contains the Lambda. But in Delphi, you saw in some of my examples, I didn't have to put self. I didn't have to do anything. I could access anything that was in the form, for example, when I had the button handler. And you can download the code and take a look at it. And also, it's it's on there's different examples as well on the doc wiki. And I think there's a generic. I think there's one other example. There's a link somewhere on the page to some additional examples that we ship. The other thing is just look at the parallel programming library. That's sort of a classic.
Yeah. That's what I did. I looked at that code and learned a lot from that because anonymous methods is one of those things that the first level is using them to call other libraries, and the second level is when you start writing your code to accept anonymous methods. And when I started doing that, I was like, wow, there's so much power and so much cool stuff I can do with this. So Neville's asking, he says, in Delphi, will it capture everything, or is it optimized to only capture what is needed in the anonymous method?
Well, you have access to everything. So for example,
it only captures what you reference in the call, right?
Yeah, I mean, you can access everything, right? For example, if you're doing an anonymous method in an event handler on a forum, you have access to the private members of the forum and so on.
Mm-hmm.
So, there's no in Delphi. There's no way you don't have to specify self, for example, as a parameter.
So yeah, once it's got self, then it has a reference to everything.
Self is there. It's just self is passed along. So I was trying to find another example. Yeah, I don't see one right here with a form. But again, download my go to Code Central and download it's 30383. I have 4 different samples in there. I'm going to add some more examples that I've been working on, and I'll update the slides and make sure those are in the same zip file. So just go to Code Central, cc.embarcadero.com, item 30383 is the item that you want. And you'll see examples where I use forms and I can access the value variable, for example, which is in the private section of the form class.
Mm-hmm.
And can you limit the capture list? I don't know of a way to limit the capture list, but I'll dig for that answer. Good question, Pat.
It's a good question. Yeah, I would check with the books to see the Marco's book and Nick's book, see if they talk about that. If there's a way to do
Runtime overhead, we're just passing a self pointer.
Yeah, with self, it's just going to be a pointer, so there's not going to be any overhead with. I wouldn't think there'd be much overhead with that at all.
Same in C++, where on a Lambda, and you'll see example. I put this in the capture list, and I put I think the value of I or the variable as well. Let's see, capture self. You can pass self as a parameter.
Well, so if you're in a record.
Oh, in a record.
Capture a reference to the self for the record from within the when you're making a call in an anonymous method.
Whatever that record is, if it's if it's instantiated as something, you can pass that as a parameter. Or since you have access to self, Marco talked about examples where if you refer to something in a structure or in a class, then it hangs around and it's replaced.
Yeah, there's not a self for a record, so you could pass a reference. You could pass your record to it, so make a call to the record, and then you'd have it. There is not a self for the record, so.
I mean, yeah. So, I mean, I would just pass the instance of the record as a parameter. I think Marco did one of the examples you saw, and you'll have to watch the replay as well. He passed the anonymous method reference inside of and used it inside of an anonymous method. So he always had a reference to it under the covers, so it stayed alive. And he's got some other examples in his book where he even can keep local variables around, where as long as he refers to a local variable in the scope of the anonymous method, until you replace the anonymous method with something else, so it doesn't have, there's no reference to it anymore, then you can even keep local variables are kept in scope.
So Neville's saying he's curious about the runtime overhead of capturing those local variables, not just self. It would seem like it'd be the same as any other call. The more local variables you're passing in, the more work it's got to do. But
again, that's just a pointer to some area of memory where the variables you have references to are kept track of, and that there's a reference to it. I guess what I'll have to do is, we could do some timing, I guess, and some memory utilization.
Go into CPU and see what's going on.
And see, but unless it's a really large structure that you're keeping, but that again, it's just a reference to it. It's in memory. It's somewhere. You're going to have that structure's storage anyway. But you're just passing a reference around, and that reference is reference counted. So, when I talked with Alan Bauer as well about all of this, and there were no real downsides that we could figure out. Some people were talking about, execution speed or how much memory is used and so on, and it's no different than just calling a method itself with parameters or using a function pointer. It's still a reference to a procedure or a function. So
Scott's saying that he says he understands you can't capture open array parameters, and wonders if there's anything else you can't capture. It seemed like anything you could pass a reference to, because open array parameters are kind of one of those oddities, but
nothing that comes to mind, but those are good questions. I'm going to save the question log, and I'll do a little more research, and I'll add some information in the blog post, and if I need to support it with an example, I'll update the zip file.
Yeah, so Neville's saying that local variables are normally on the stack, which would be gone once the method's gone, but then with an anonymous method, it keeps those even when the calling function has gone out of scope.
Unless
that's correct.
The anonymous method. If there's nothing referring to the anonymous method anymore, again, Marco talked about that in his little demo, and he covers that in his Pascal book. And I'll find that section of the text, and there may be a PDF subset somewhere besides the ebook that you get when you update. But if I can dig up a quick little example, because in his example he replaced the anonymous method, so there was no reference to the local variables or anything else associated with that anonymous method. So since there were no more references to it, it kicked it out of memory.
Right. Okay, I think we've gotten through the questions. There's some real good questions here.
I was just typing in. There's nothing really that comes to mind as far as serious overhead. And again, if you have some very large data structure that you have a reference to and you want to keep it around for a long time, well, if it has if you have a reference that's active to it, it's got to keep it around.
So now, when you capture a local variable, is it passing it by value, or is it passing by maintaining a reference to it, or what's going on there?
It's my understanding it's a reference.
It's a reference. Okay. So yeah, so that's more efficient than to pass a reference to it. So Neville's saying, so anonymous methods are auto-reference counted like strings and arrays?
If you have a reference to the anonymous method and you're using it somewhere else, like in Marco's example, I think he had it as a parameter that was being used by some other code, then it's still there. But when it's gone, yes, the reference is decremented. There's no reference to it. It's released. So what I need to do is do a simple little example to show you maybe a visualization of references. But Marco covers that in his book. So
I was going to say, I think the video Marco was showing there too also showed a little bit with the references, the add ref, release ref, and stuff like that.
Yeah, you have three choices. Invoke. I think he popped it up. There was construction, invoke, and then there was reference count.
Yep.
I forget the fourth one. I always have to see it again. I usually just use parameter insight and have it pop up, and that's your choice. So, internal implementation of anonymous methods. Yeah, I'll find. I don't know if Marco does it in his book to see if there's sort of a memory reference diagram. But for me, the best way is I'm typing code and I bring up code insight, and if it's anonymous method, you'll see like the name, and then you can hit dot, and you'll see the four things pop up, and one of those is a reference count. Yeah, and Marco showed that in the video, so you can watch it in the replay. But I'll see if I can find a sort of memory diagram with captured variables and local variables that are reference counted into.
Oh, sorry, it seems like I remember Alan Bauer did a code rage session at some point about anonymous methods.
Well, he did the parallel programming library, and he talked about that.
Well, it seemed like there was one way back when anonymous methods were first introduced. It seemed like I remember seeing Alan Bauer walk me through explaining all of it, and a lot of it was just like, wow, this is magic. But I can't remember exactly. Does that sound familiar at all to you, or?
I don't remember, but I'm going to look for some kind of memory diagram utilization for anon methods. I don't remember seeing one. There isn't one that I found in the documentation, so maybe we need to do one. I don't remember seeing one in Marco's book, but I'll look in Coding in Delphi, next chapter. I'll look in Marco's book, and if I can find kind of a memory representation diagram, I'll put the picture in this blog post that is my blog post about the skill sprint.
All right, cool.
Yeah. And if I can have an example that sort of illuminates that, I'll add to the zip file. And you can watch the replay when Marco talks about the capture and reference counting in his demo. I'll have the replay up as soon as humanly possible. Because he did show a spot where he showed, instead of calling invoke on this sort of event handler anonymous method, he showed that there's also reference count as one of the choices you could use to get the count. So I think a demo that displays the current reference count for an anonymous method.
Here we go. I found a blog post Alan did about variable capture. Not what I was looking for, but still looks very useful.
So you can put that in, I don't know where, in the chat window or wherever, maybe?
Yeah, I put it in the chat window, so everybody should see that there. Hopefully everybody sees that. So that one's worth checking out. I mean, that's what I'm thinking of. When reading that, I heard it in Alan's voice and imagined him explaining it to me, but it may have been what I'm thinking of.
Yeah, value versus variable, yeah.